Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly share, like, comment and subscribe for more interesting videos and updates. Today we are going to consider the squeeze theorem. Imagine you have an orange and you are squeezing it, alright? The squeeze theorem or the sandwich theorem. That's a very interesting topic so far as calculus is concerned. Now, at times you'll be given limits of functions, okay? And now, some limits of functions are very difficult, okay, to evaluate directly. But so far as you know this squeeze theorem, you can simply work out for those limits of functions without any difficulty. Alright? Good. And now this squeeze theorem is mostly applicable to oscillatory functions, okay? Functions that are oscillating. What do we mean by oscillatory functions? Functions of, let's say, function, the tangent function, and what have you, secants, cosecants, cotangents, and the likes. You simply what? Recall or invite what you call the squeeze theorem. Now let's start the business. If I have a function, say f of x, which is less than or equal to a function, say f, let's say j of x, which is also less than or equal to h of x. Now, let me apply limits, okay, of the whole function given here. So I have, applying the limits, I have lim of f of x. As x approaches a certain value, x is nearer to a certain value, say a, which is less than or equal to lim of j of x. As x approaches a, is less than or equal to limit of h of x as x approaches a. Alright, good. Now, by the squeeze theorem, so by the squeeze theorem, what I'm trying to say is, when you evaluate, okay, or when the limits of the very first function, okay, is equal to, that means when you evaluate the limit of the very first function and is equal to the very last function. So let's say if you evaluate this and you have a function, sorry, when you evaluate this function and you get L, okay, you're assuming L is the answer, okay, when you evaluate this. And when you also evaluate the last function and you also get L, once they are the same, that value L is equal to the limit of the middle function. So what do I mean? So if I have if lim as x approaches a of f of x this way is equal to lim as x approaches a of h of x this way, which is equal to L. In other words, when you put a into this function, you have L. When you put a into this function, we have L. So since L is equal to L, do you get that way? Now, this squeeze theorem is telling us that this L, okay, is equal to the limit of the middle function. As simple as that. So therefore, by the squeeze theorem, we can say that lim as x approaches a of j of x is equal to L. As simple as that. Now, to make this more practical, let's consider, let's say you having a bread, okay? You went to the market, you purchased a bread, and probably you want a fried egg, right? Inserted in between this bread. So I have a bread, okay, then you cut through the bread. So when you cut through the bread, we have the upper part of the bread, and we have what? The lower part of the bread. Then, obviously, or let's say, you would prefer to insert a fried what? Egg in between. Now, the top part of the bread represents, let's say, your f of x. And the bottom part of your bread represents this function, which is what? H of x. Now, when you evaluate the top and the bottom, okay, what you get is equal to the fried egg, which is what? Which is your g of x. As simple as that. To throw more light on this, let's consider when you have, let's say this, okay, this is limits of f of x, okay, as x approaches a, this. And the last function, okay, that's the limit of h of x as x approaches a. There's it. So you have the top part and the what? And the down part this way. You have the top part and the down part. Now, when you evaluate the limit of the top part of the function, this function, and we also evaluate the limit of the bottom function, okay, the answer you get, let's say it's called L. So that L is equal to the limit of what? Of the middle function. So in this case, this is our middle function. So there's it. So this is simply what? The squeeze theorem. Let's use this, okay, to apply for like questions, okay, so that we can be able to appreciate squeeze theorem. Okay, viewers, so let's consider the question. This: show that limits of x squared multiplying sine 1 over x as x approaches 0 is equal to 0. So this is an example of an oscillatory function, right? Good. Now, before we can attempt this question, this is what we must know. You have to know the domain of, let's say, the sine function, and as well as what? And as well as the range of the sine function. But our interest here is the range for what? For the sine functions and not the domain. So now we know that the range of a function simply tells us the output, or it's just the output of what? Of a function, right? Good. So now it doesn't matter, okay, no matter what value you insert into the sine function, it will give you an output, and that output of the function cannot go beyond 1 and below -1. In other words, we have -1, okay, less than or equal to the sine function, that's sine x, less than or equal to 1. So in other words, this is what? This is the range. To throw more light on this, the sine function from the origin, it oscillates this way. So this is the maximum value, okay, that's 1, and minimum value of what? Of -1. So I write the inequality statement, okay, this will be the result, okay. So in other words, it doesn't matter, okay, no matter what value you insert, okay, into the function, this is the output, and the output cannot go beyond 1, and it can also what? Go below what? -1. As simple as that. So we are now going to build on this, okay. In other words, we are going to adjust this in order to solve the question. So how are we going to do that? Alright, so we have length of this whole expression. Now let's do comparison. If you are saying negative 1 less than or equal to sine x less than or equal to 1, here we're not giving sine x, we're rather giving what? Sine 1 over x. So this is the same as we have negative 1 less than or equal to sine what? 1 over x less than or equal to 1. Okay, so what can we do to this, okay, to this, in order to get something like this? So we have to what? We need to adjust this. We need to manipulate this. So here I have sine 1 over x. Over here I have what? Sine 1 over x. What's happening here? I can see what? X squared multiplying this, right? So as a result of that, I'm also going to multiply through by what? By x squared. Do you get it that way here? So multiplying through by x squared, what do we have? So in other words, we are multiplying the whole of this by what? By x squared. So x squared times negative 1 gives what? Negative x squared. Less than or equal to x squared multiplying this gives x squared sine 1 over x. Then less than or equal to, again, x squared times 1 gives x squared. As simple as that. Now viewers, what do we do here? You take limits. You take limits. So we have lim as x approaches, viewers, from the question, as x approaches what? 0, right? 0 of negative x squared less than or equal to limit as x approaches 0 of x squared sine 1 over x less than or equal to, then limit as x approaches 0 of x squared. So we are going to evaluate this and evaluate that. Now viewers, when you put x is equal to 0 into this, we will have 0 less than or equal to, viewers, we are not going to touch the middle function. Why? Because that is the question. So the question, we have lim x squared sine 1 over x. Over here, lim x squared sine 1 over x. As x approaches 0, as x approaches 0. Do you get it that way? So in other words, we are going to what? We are going to maintain the middle function, okay? So we have lim as x approaches 0. Then we have x squared sine 1 over x less than or equal to, when you put x is equal to 0 into this, we are having what? We are having 0. Now, what is the squeeze theorem saying? So by the squeeze theorem, we would say that the middle, okay, so we have limits as x approaches 0 of x squared then sine 1 over x is equal to L, where L here is equal to what? 0. As simple as that. So therefore, you can say that length of the whole expression as x approaches 0 indeed equals what? 0. They said we should prove, and that is simply the proof. So viewers, using the same concept, let's work out for the second one. What is the limit of x to the power 3 cos 1 over x as x approaches 0? The answer is simply 0, right? Okay. What do we have? We have x cubed, then cos 1 over x. Okay, they say as x approaches 0, set limit of this as x approaches 0. They're asking what is the limit of the whole expression this way. Okay, what do we do? The range for sine function, okay, is the same for the cos function. So we already know that our negative 1 less than or equal to cos what? Cos x. But here we have what? Cos 1 over x. 1 over x is less than or equal to what? 1. So viewers, remember I said we are going to what? We are going to adjust this. So what do we do here? From the question, you can say cos 1 over x. Over here you can say cos 1 over x. But what do we know? Here, you can say x cubed multiplying cos 1 over x. So we are also going to multiply 2 by x cubed, right? So multiplying 2 by x cubed, we have negative 1 times x cubed gives what? Negative x cubed. Less than or equal to, multiply here by x cubed, we have x cubed, then cos 1 over x. Less than or equal to 1 times x cubed gives what? X cubed. What can we do again? Take limits. Okay, so we have lim as x approaches 0 of negative x cubed less than or equal to x cubed, then we have cos 1 over x. So we have the limit, okay, limit as x approaches 0 of x cubed. Remember we are taking limits of this, and limits of that. We have cos 1 over x, then less than or equal to, then limits as x approaches 0 of x cubed, x to the power 3. Viewers, clearly when you put x is equal to 0 into this, when you evaluate this, you will get 0. So you have 0 less than or equal to, then limit as x approaches to 0, you have x cubed cos 1 over x, then less than or equal to, when you evaluate this, you get what? 0. So now, by the squeeze theorem, so by the squeeze theorem, since this is equal to this, in other words, L equals L. So therefore, L is equal to the limit of the middle function, right? So therefore, you can conclude, you can say that the limit as x approaches 0 of x cubed times cos 1 over x is equal to 0. As simple as that. So viewers, let us appreciate. Okay, viewers, the question reads, okay, that's our third question reads, if square root of the expression 5 minus 2x squared is less than or equal to f of x, less than or equal to the square root of the expression 5 minus x squared for negative 1 less than or equal to x, less than or equal to 1. Find limits of f of x as x approaches 0, right? Good. So this is the question. So what can we do here? Take limits. Or you realize that this is giving what? Squeeze theorem application, okay? You can apply squeeze theorem here directly. So let's take limits and let's see what happens. So I have lim as x approaches 0 of 5 minus 2x squared less than or equal to lim as x approaches 0 of what? Of f of x less than or equal to, then limits as x approaches 0 of 5 minus x what? X squared. Viewers, if you evaluate this, you have root 5, square root of 5. But let me show working. So we have 5 minus 2. Then wherever you see x, that place goes to 0. So I have 0 what? Squared. Less than or equal to lim as x approaches 0 of f of x. Less than or equal to, then I have 5 minus, wherever you see x, it goes to 0, then what? Squared. So what do we have? We have root 5. So negative 2 times 0 squared is simply 0. I have less than or equal to, I have lame as x approaches 0 of f of x. Less than or equal to what? This whole part goes to 0. I have a square root of what? Of 5, right? So by the principle of the sandwich theorem, so by the squeeze theorem, we know that this, the middle function, okay, viewers, one hint is this. Our interest, okay, is always, okay, on the middle function. Target that side. Why are you saying that? Look, the question said here, what is the limit, okay, of, this, if this is less than or equal to this, is less than or equal to this expression. Now the person says, find limits of f of x as x approaches what? 0. So you see, we are interested in what? In the middle function. So whenever you manipulate, okay, and you realize your middle function here is not equal to the question, then that means what? There is a problem. So with the help of Tindanious Maths and Science YouTube channel, these problems will be solved, okay? Your ability to realize this problem at a faster rate, okay, is just what? You watching Tindanious Maths and Science tutorials. Though problems are inevitable, right? But with this channel, you are known or you are trained to be what? To be a solutionist. Right? Good. So subscribe for more interesting updates. So by the squeeze theorem, the middle function, okay, our interest, so we have lim of the middle function, the limit of the middle function, which is lim of f of x as x approaches 0 is equal to what? Is equal to square root of what? Of 5. As simple as that. Let's consider this. If the expression 2 minus x squared less than or equal to j of x less than or equal to 2 multiplying cos of x for all values of x, okay, find limit of j of x as x approaches 0. Someone will be asking, sir, is it always the case where x will approach what? 0? Not at all. Even this last question, what do we have here? We have negative infinity. It will be what? Positive what? Infinity. Alright? Good. So this is the question over here. So apply the limits, okay? So you have lim as x approaches 0 of the expression 2 minus x what? Squared. This way. We have less than or equal to, we have limit as x approaches 0 of the j of x less than or equal to lim as x approaches 0 of 2 cos what? X. Now let's evaluate this. So we have 2 minus, wherever you see x, it goes to 0, minus 0 squared, right? Less than or equal to lim of the middle function, which is j of x, less than or equal to, we have 2 cos, wherever you see x, it goes to 0 times 0 this way. So what do we have? We have 2, okay? Everything here goes to 0, right? Less than or equal to lim as x approaches 0. We have j of x less than or equal to cos 0 is simply 1. So 1 times 2 is what? Is 2. So by the sandwich theorem or by the squeeze theorem, what do we know? We know that the limit of the middle function, which is g of x, is equal to L. It's equal to L. But in this case, our L equals what? Equals 2. Have you seen how simple it is? Now let's tackle the last question. Alright. Okay, the fourth question reads, evaluate the expression 4x squared minus cos 5x all over the expression x squared minus 7 as x approaches negative infinity. Wow, I love this question. Alright, good. So with this channel, okay, this question types, okay, will become very simple for you. Alright, okay, we have this question. Remember, we have what? We have a cos function, right? A cosine function. So let's write the range. Okay, good. So we already know that -1 less than or equal to sine x. Sorry, for cos. Cos what? Cos x. But in this case, what do we have? We have what? 5x. 5x. Then less than or equal to 1. Is that also good? The second thing is to manipulate this. Alright, so what can we do? Here we have cos 5x, we have cos 5x. Fine. But we have what? Negative cos 5x. But here we have what? Positive cos 5x. So what do? You multiply through by what? By negative. So -1 times negative. What do you have? You have +1 this way. So whenever you are multiplying through by negative, okay, the inequality sign what? Reverses. Right? Good. So this one reverses to what? Greater than or equal to. Then you have cos. You have negative what? Cos 5x. Negative because we are multiplying through by what? By -1, right? Good. Then what do we have here? Because we are multiplying through by negative, this sign will also what? It will reverse. So we have greater than or equal to what? -1. So viewers, what we can do here is we can flip this. Okay, so what I have -1, okay, because I'm flipping it, I will reverse this. For example, if I have s is greater than or equal to 2, and I want to flip this, I will say what? 2, then I will reverse the sign, less than or equal to what? X. So we are going to apply the same concept over here. So because I'm flipping, I have -1, we reverse this sign. So what do I have? I have this, less than or equal to what? Negative cos 5x. Then what happens here? You reverse the sign because we are flipping. So what do we have? We have less than or equal to what we have? Positive what? 1. As simple as that. Why did I flip? I flipped because we want what? Because we know that for the range of the cos function, it starts from what? -1 to what? To +1. So I just flipped so that we wouldn't what? We wouldn't be confused. Alright? Good. So what do we do next? We have negative cos 5x. We have negative cos 5x. That's fine. What do we do next? Okay, we can do this. You realize that 4x squared was added to this. Is that also? So in view of that, we are also going to add what? 4x squared to the whole of this. Whatever you do to the left hand side, you do same to what? To the right hand side. So I will add 4x squared throughout. So I have 4x squared being added to -1. So plus -1. Negative and +1, they commute. You have what? Negative, right? So I have -1. You have less than or equal to, you add 4x squared. So you have 4x squared being added to You see, being added plus negative what? Cos 5x. Negative and positive, when they commute, what do we have? We have what? We have our negative. Then less than or equal to, what do we have here? 4x squared being added to what? Being added to 1. As simple as that. So viewers, let's compare. I have 4x squared minus cos 5x, which is the same as what? The numerator. But you realize that everything here is divided by what? X squared minus 7. So I will do that. So dividing through by x squared minus 7. So I'll divide through by what? X squared minus 7. So what do we have now? So I can say over what? X squared minus 7. Here to by what? X squared minus 7. Over here by what? X squared minus 7. Viewers, let's compare again. Is the middle function, okay, equal to the voice of the question? We have 4x squared minus cos 5x. 4x squared minus cos 5x. We don't have any problem, right? Let's consider the denominator over x squared minus 7. We have x squared minus 7. So we can now proceed. So what do? You now apply limits across, right? So applying your limits, we have lim as x approaches negative infinity of 4x squared minus 1 all over x squared minus 7 less than or equal to limits as x approaches negative infinity of the middle function. We have 4x squared minus cos 5x all over x squared minus 7 less than or equal to limits as x approaches negative infinity of 4x squared plus 1 all over x squared minus 7. Viewers, when you evaluate this, you get 4. You get 4. So viewers, I will do a video, okay, on how to evaluate limits at infinity, okay? Everything will be explained, okay? So let me just show working over here. Now if you want to evaluate limits at infinity, what you do is you consider or you pick the highest degree of the denominator. So here what do we have? X squared, okay? When we consider the denominator, we have x squared, okay, being the highest, okay, that's the degree, right? So what we do is you divide the highest degree of the denominator by the numerator and the denominator itself. What do I mean? So if I have 4x squared this way, right? Now this is what we are going to work with. We are dividing it by the degree of the highest denominator, right? Which is my x squared. So let's assume if I had here to be s cubed. Viewers, I will consider what? S cubed. Because the degree here, 3 is higher than what? Than the 2. Do you get it that way? So in this case here, it was 7. So obviously we are just going in for what? X squared. So you now pick the numerator, which is 4x squared. You divide it by the highest degree of the denominator, which is what? X squared. What do I have here? Minus 1 over the highest degree of the denominator, which is what? X squared. Then all over the denominator itself. What do we have? X squared over the highest degree of the denominator, which is what? X squared, right? Then minus 7 over x squared. As simple as that. So I have less than or equal to lim as x approaches negative infinity. Then have 4x squared minus cos 5x. Then all over x squared minus 7. Then less than or equal to, you do same. So x squared and 7. The highest degree of the denominator is what? X squared. So I have When you consider the numerator part, you have 4x squared dividing what? X squared. Then plus 1 over x squared. Then all over the denominator x squared over x squared minus 7 over x squared. As simple as that. So viewers, whenever you have something like 1 over x squared this way, right? Or 1 over x. Okay, you have the limits as s approaches infinity or negative infinity. The result is 0. Always, okay, the result is 0. And I'm going to prove why it is so. So click on the bell button or the subscription button to subscribe to my channel, so that when I post these videos, okay, you can receive updates, okay. So just leave this for me. I'm going to prove this, right? But for now, when you have something like this, it goes to what? It goes to 0. So you have limit as s approaches infinity of, that's 1 over x. The result is 0. So viewers, you can cancel out. This cancels this, right? This also cancels this. What do I have? I have 1. I have 4 over 1. 4 over 1 is the same as 4. The whole of this is 4. Then minus, viewers, remember, you have 1 over x squared. Right? 1 over x squared. What happens? What happens? It goes to what? It goes to 0. So I have minus 0. Then all over, what do I have here? S squared cancels x squared, 1. Then minus 7 over x squared. When you take the limits, okay, at infinity, it also goes to what? It goes to 0. Right? Then less than or equal to the middle function, which is what? Lim as x approaches negative infinity of 4x squared minus cos 5x all over s squared minus 7. Viewers, this cancels this. So what do I have? I have 4, then plus 1 over x squared. The limits at infinity, okay, at 1 over x squared goes to 0. Then all over, viewers, this cancels this 1. Then minus 7 over x squared. The limit over there at infinity goes to what? It goes to 0. So viewers, for want of space, let's go to the other side. So we have 4 minus 0, then over 1 minus 0, less than or equal to lim as s approaches a negative infinity, then of, viewers, I'm just doing copy and paste, okay, have lim of 4x squared minus cos 5x over x squared minus 7, less than or equal to 4 plus 0 over 1 minus 0. So viewers, the whole of this gives 4. Less than or equal to lim as s approaches negative infinity of 4x squared minus cos 5x all over x squared minus 7. Then less than or equal to, when you evaluate this, you are getting 4. So by the squeeze theorem, what do we know? We already know that now the limit as s approaches this negative infinity, okay, of the middle function 4x squared minus cos 5x, then all over s squared minus 7 is equal to 4. Viewers, this is the end of the squeeze theorem or the sandwich theorem. So in summary, this is what we have said so far. When you have your graph this way, this is your y-axis, this is your x-axis. Then let's say you have any continuous curve, okay, any continuous function at all. Let's say you have a function this way, okay, all right, and let's say this is f of x. Then let's say you have another function this way. Let's say this is called g of x, and you have a third function, okay, somewhere here, and this third function is sandwiched between f of x and g of x. Let's call it h of x. So to evaluate the limit over here, okay, so let's say from here up to here, we have c, all right. So now let's look out for the corresponding y value over here. So from here then up to here, we have a value called L, okay. So the limits, okay, provided this is equal to this, okay, the limit of this, when you evaluate this, and you have the results to be L, okay. Now this result L is equal to the limit of the middle function, which is what? H of x. This is simply the geometric analysis of the squeeze theorem. Also note this, the range for the cos function is the same for the sine function. I mean the range, that's the range. So the range is, that's -1 less than or equal to, let's say, sine x, right? Or in this case, you can say -1 less than or equal to y, less than or equal to what? Equal to +1. That is the range for both sine and cos. And the domain is still the same. So for the domain, we have negative infinity less than x, then less than positive infinity. As simple as that. I'll see you next time for another interesting videos and updates. Bye.